Okay, recording now. Sharing my screen. Okay, so yesterday we got to this point. In fact, what I'll do is I will post this video today for some individuals who did not take notes on Friday or who were not here. So this is what the first page should look like. It has different definitions and examples. And this is what the second page should look like. Only on two steps in, and this is what the third page should look like for examples so far. All right, so today's Farm Animal Day. If you would like a farm animal prize, and I will definitely show you them once you volunteer. But 2, 3, so many roosters. Get those roosters out of here. 85 roosters in here. Okay. So now here's the thing, and this is confusing. So far what we've done is we found a mean, and then we wrote down all the data points, and then these are the deviations. This is how far things are above or below the mean. And I think it was Jerry, tell me if I'm right, Jerry, who said that the reason why there's 4 above and only 2 below is because the 2 below were so significantly low.
Indeed, I did say that.
Okay, now here's the thing. Everybody right now, I want you to add these up in your calculator. Add up these 6 numbers in your calculator right now. I'm definitely going to ask to see your notes at the end of today, so make sure if you're one of those people who didn't take notes the first time that you are taking notes this time and ready to show me. Welcome back, Tyler. Bad internet today, Tyler?
Yeah, it just cut me out. Sorry.
It's okay. So let's see, that's 20 kids in class. Which makes sense since we're missing Ethan. Okay, so somebody unmute and tell me what you got when you added them up.
I got -0.2.
-0.2?
Yeah.
Okay. And the reason why it's a little off is because we're rounding. What should happen when you add all these up every single time, no matter what the problem is, you should get 0. Anybody have an idea why? Why they would all add up to 0? I mean, this time they added up to 0.2 because we rounded a little bit, but anybody have an idea of why all of these positive and negative deviations would add up to 0 every time?
It's got something to do with, like, it's the averages, like, so we're looking for the average, or like the average wouldn't be that far away from 0 because that's what our average is.
So some of them are below, right? Significantly below, and some of them are above, a little bit above. And they're equally around the average in some way. They basically cancel each other out eventually because it is the average. So here's the problem. If we're trying to find an average deviation, normally what we do if we find an average is we add them all up and we divide by 6, right? Because there's 6 of them. But if we add these up and divide by 6, we're going to get like 0 again. And that doesn't help. So the next step we have to do, and I'm looking for somebody brilliant who's got a brilliant idea here, okay? We have to try some sort of mathematical thing that is going to make all of these positive, because we want, essentially, to get rid of the negatives. We want them all to treat them all like deviations, like this one deviated by 11. It doesn't matter that it was negative. These ones deviated by 2.8. Doesn't matter that it was negative. So what's a mathematical thing we can do to make something positive? But here's the trick. It has to have a way you can undo it too.
Could you multiply the 2 negatives, possibly?
Well, we kind of want something for every single one of them. So I don't
Oh.
want to just take two of them and multiply them. Good idea, though, Mitchell.
We multiplied them by themselves.
Yes, we're going to square them. And because does that make sense to everybody? If we square them, then they'll all be positive. And if we do a square root, we can undo it. Mitchell, that was a brilliant answer. Would you like an I'm a winner sign? Or I'm going to show you all the animals that you don't want. Okay, there's a pig and a cow and a dog and a rooster and a horse. But you don't want those.
I'll take the I'm a winner sign.
Yeah, you will. To be honest, Mitchell, that was more just me showing like Megan her options for later rather than you. Okay. Okay, so the next step is I'm going back to my direction sheet. And if you did not write down directions last time because you were gone, or maybe you weren't making a good choice, then now you can write it down. So here's our third step, is to square all the deviations. Which in the formula side here is going to look like x minus mu squared. And that's how we're going to make them all positive. Okay, I'm going to randomly pick some people in class to fill out this column, which is x minus mu squared. That's our third step, which means you're going to square every single one. So go ahead and do that work right now. You should be doing all 6, squaring them.
Miss Nussbaum.
Yeah?
So we just take the first column minus the second column squared, right?
Well, you don't even have to do the first. This x minus mu is column already. So you just have to square these. So like for the first one, you would square 1.8.
Oh, yeah, okay.
For the second
Oh,
one, you're going to square, yep, negative 6.2.
Okay.
Everybody should be doing this. Do not get surprised when I call on you. Even the people who are gone, even the people who didn't take notes the first time, you need to be able to square these, which means you're taking this times itself, or this times itself, or this times itself, or that times itself, etc. Hey, everybody got their calculator out? Getting this done? All right. Let's start with number 8, which is 1, 2, 3, 4, 5, 6, 7, 8. Jade. You always get picked by the calculator, Jade.
I got 3.24.
Okay. How about, let's see, number 3, Morgan.
I got 38.44.
Yep, 38.44. Everybody should be writing this down. You need this information later. Next up is number 6. 1, 2, 3, 4, 5, 6. Caitlin.
23.04.
Okay. And then Jesselyn.
125.40.
Okay. And next up is Michaela.
7.84.
Good job. And finally, we've got 7, 8, 9, 10, 11. Justin.
60.84.
Good job. Okay. So now our whole idea behind finding the average deviation is that we were going to add them all up and divide by 6. So let's do that next. Grab my book quick. All right, so our fourth direction is add up all the squared deviations. Which, if I'm going to do a formula, is the summation of x minus mu squared. And then we're going to divide by the sample size, which is the summation of x minus mu squared, all divided by n being the sample size. I'll give you a second to make sure you're caught up. Okay. So then I'm going to go over here. And right here, we're going to need to do a summation. And then we're going to divide by 6. So all right, I'm going to call on 2 random people who are going to tell me these all added up first, and then that number divided by 6. All right, so Jason, can you tell me what these all add up to?
I got 262.84.
I did not get the same thing. Did somebody, do you guys agree with Jason?
I got 285.84.
I did not get that.
I got 258.84.
That's the one.
58?
I
258.
got 258.84.
Yeah, I got 258 too. I just read it backwards.
Okay. All right, Jason, you must have just mistyped something in your calculator. That's no big deal. And then Natalie, can you tell me what that number divided by 6 is?
43.14.
I agree. Okay. Now this is got a sigma by it. It's like a little O that has a line coming off the top of it. And this is called the population variance, which is something that you do not need to know really what it is. until you get to AP Stats, but for those of you who are going on to AP Stats, that'll be important later. So I'm going to write right here, this is equal to sigma squared on my notes. All right, I'm looking for the last step. Last step to get the standard deviation. Do you guys remember how we were trying to do something that we could undo later? So raise your hand virtually if you can think of the last step to undo what we did earlier. We did something to make them all positive, and then we want to undo something. We want to undo it in a way. All right, Mitchell and Megan. Mitchell, you're 1, Megan's 2. 2, Megan.
So we squared them before, and now we have to find the square root of 43.14.
That is exactly right. All right, so I'm going to write for my step 6, square root, the previous step. And that equals population standard deviation, which is denoted by sigma. That little, some kids used to bother me and call it O-tail, which I hated. Imagine going to college and being like, hey, and then I found the O-tail. What? Although I will say that some names in stats are absolutely ridiculous. For example, one of the things that is in stats is this. Anybody want to guess what that means? It's a really stupid name. Just unmute, take a guess. It like looks what it is, looks like what it is. As much as the other one's not called O-tail, this is called something like that. It's called p-hat, as in P with a hat on it. P-hat, also spelled like the word fat. Isn't that nice? Okay, super cool, obviously. But yeah, that's called p-hat, which I think is very funny. Okay, so normal teachers, not me, would have just given you this formula to begin with. This is how you find the population standard deviation, but I wanted to do all the steps. So the last thing we need to do is take the square root of this. All right, and the person that my calculator says is going to do that is nope. Jordan.
Yeah, 1 sec, I'm doing it right now. I got 6.56.
Yep, agreed.
Did I do that right?
Well, yeah, 6.57, I think. All right,
Oh,
and
well, yeah, wrong. Okay.
it is the population standard deviation. Okay, so, oh, Megan, I forgot to give you a prize. Here's all of your animal choices.
I want the pig.
Okay. I like how you're like, I knew what I wanted long ago. Okay, so now what we have to do is I want to go back to that first page. Remember how we skipped writing the formula on that first page? And I'm just going to fill that in right now. the same formula that's on the very end step of our notes. It's like Logan got booted. Okay, so now we're done with the notes. And what we're going to need now is we're going to look at the homework. The homework is actually only one problem, but it's one of these standard deviation problems, so it takes a little while. So I want to talk about it quick. We only looked at the first 6 games. The next 3 games went like this. 47 to 0, 43 to 22, 0 to 20. Okay. All right. So what do you think? Our average before, it looks like our average as a football team before was 25.2 points per game. Pretty high. And our standard deviation, remember, that's about how far we vary from this, which means that we normally score somewhere between 19 and 31-ish, 32-ish points. Okay, that's normally where we fall. This is kind of like a plus or minus on either side, okay? So what do you think? Somebody unmute and tell me, do you think that our average got higher or lower if we add in 47, 43, and 0?
Lower.
Lower, you think? You think it's the 0 that hurt us?
No, I think it's higher because we had 2 much bigger than before, and then 1 like kind of the same scale. It might have like been like kind of the same, like just a little bit higher.
Yeah, even if you take like 47 and 43 and 0, you get 90 divided by 3. The average of those 3 games is 30, which is higher than our current average, right? Okay, so it's probably going to bring our average up. Do you think that our population standard deviation is going to go up or down? Do you think we're going to vary more? Are we less consistent or are we more consistent?
I feel like less consistent because that last game is like really, really out of there. Like we had
Right.
47,
If our
40.
average is 25 or something, this is way below it. And if our average is 20, these are pretty high too. I mean, even our beginning ones, look, we weren't in the 40s to begin with. So you're right. I think we're varying more. We're getting more outrageous as in getting really good and having like one really bad game. Okay. So what you need to do is need to find the new mean, the new standard deviation, and the new variance. You're going to have to redo your chart from the previous work and add in the new games as well. So when you make your chart here, you're going to have 3 columns and now 9 games. Follow the steps like we did in the previous problem, but be careful because your mean will now be different. These will be the same, 27, 19, 30, 14, 28, 33, and then we're adding in 47, 43, and 0. But now your mean is going to be different. So don't, for this problem in your homework, don't keep using 25.2 as your mean. Follow all the steps, and that's it. That's the only thing that you have to do for homework, just one problem. Okay, so I'm gonna stop recording. Give you one more second to write that down. Just the problems. And remember, this is just the original chart plus the new 3. Okay.